Okay, children. Yeah. Okay, yes. So this is our first lesson. And yeah, we just found out that y'all are all at different topics in school. Yeah, actually that is because algebra at primary 6 is still a very, very basic topic. And they didn't want to go too deep into algebra for primary 6 yet. So because of that, some schools decided to teach later. But there are also some schools that actually make use of algebra because they want to teach the children how to formulate the equations and so on. And from there, right, when they move on into topics like fractions and ratio and percentage, some schools actually encourage the students to make use of algebra to solve. Yeah, because if you are able to do that, right, yeah, using algebra to solve is actually definitely much faster. Okay, so yeah, just now I heard from y'all that y'all have actually seen the video, so I think we can get started with our questions. Now, before we go into those questions, let me just give you a very quick what you call idea, okay, of what algebra is all about. Yeah, okay, so now algebra is actually a field of mathematics in which we make use of the letters of the alphabet to represent the unknown numbers or the unknown quantities. So when we form our equations, right, you will see things like there's an X here, there's a Y there, or there's an A here. Okay, all these are the letters which represent an unknown number. Okay, now, of course, in arithmetic, we only make use of numbers. So all the way up to primary 5, like when you form equations, like for example, 2 times 3 plus 4, all these are known as equations, and they are all just numbers. So in arithmetic, you only see all these numbers and you see all the plus, the minus, the times, the divide, and so on. But in algebra, okay, some of the numbers are represented by letters, and these are called the unknowns. Now, some of these equations, right, actually have functional relationships. So what are functional relationships? Functional relationships means the value of this unknown letter, right? Sometimes it is dependent on another another value. Okay, for example, let's say we know that the length of a rectangle is twice of the breadth. So because the length is always twice the breadth, we know that this is known as a functional relationship, which means if the breadth is 2, the length must be 4. If the breadth is 3, the length will be 6. So this kind of functional relationships can actually be represented in algebra. Yeah. Okay, so now we look into the rules in relation to algebra. So we'll actually do a very quick comparison with arithmetic. And then after that, we'll look at the algebraic equations. All right, so very simple ones. So nothing to be afraid of. Let's say we start with addition, yeah? Addition in arithmetic, like I say, is purely all numbers. So it is something like 1 plus 2 is going to be equal to 3. But when we are talking about algebra, we have to use a letter, right? So it can look something like that. 1 plus A equals to 3. Yeah. Alternatively, I can flip it around. I can say A plus 1 is equal to 3. So if we are looking at algebra, then will the value of A that is found here and the value of A that is found here, will they be equal? Okay, so that is what we would like to know. And the answer is actually yes. Okay, the letter A will have the same value when I flip the equation around. Okay, and that is because in mathematics, addition actually has this property called commutative property, in which we can actually swap the numbers around. You will still get the same total. All right. It is like 2 apples plus 3 apples, I will get 5 apples. If not, then I say 3 apples plus 2 apples, I will also get 5 apples. All right. So that is the main idea. I can swap them around. Okay. So for addition, we have this commutative property. But what about subtraction? Okay. So let's quickly take a look at subtraction. Now in subtraction, in arithmetic, again, we are just using numbers. So for example, 3 minus 1 equals 2. But in algebra, I can form an equation something like this. 3 minus a equals 2. All right. But what if I were to swap the 3 and the a, and I were to write it as a minus 3 equals 2? Okay. Will the value of a be the same for both equations? Will it be the same? Any of you? Anyone knows whether they'll be the same? Okay, I think you are very shy. Yeah, nobody is brave enough to tell me, but it's okay. All right, it's okay. Never mind. Okay, so now in subtraction, yeah, you will realize that in this equation, my a actually takes a value of 1. So 3 minus 1 equals 2. But in the other equation, when I swap, right, the value of a actually takes on this number called 5, because 5 minus 3 equals 2. So are the two values of a equal? No, they are not. Okay, they are not equal. So in subtraction, it does not follow a commutative property. So you have to be very careful. If it is supposed to be a minus whatever in your equation, you cannot make that mistake of writing a number and minus a. Okay, it is very, very important that we do not make that kind of mistakes. All right. Okay, so subtraction, you have to be careful. Now we move on to multiplication. Now, so in multiplication, in general arithmetic, for example, I throw in two numbers. For example, let's say 3 times 4 equals to 12, right? Now, in algebra, one of these numbers, I will use a letter. So, for example, 3 times a. And obviously, because I don't know what's the value of a, right? So the only thing in algebra is when you have a multiplication, what we will do is we will remove the times sign and we will join the number and the letter together. And it will look like this. So 3 times a is equal to 3a. All right. Now, what if I were to swap it around and put a times 3? Okay, a times 3, we will also just join them together and we just call it a3. Okay, but the thing is this, in primary 6, we will still accept it if you write it as a3. But once you go into secondary school, we will insist that whenever you have a letter and a number joined together, we put the number in front, we put the letter behind. Okay, so it will always look like 3a instead of a3. Okay, but will the values be equal? Okay, if you were to look at the two equations themselves, right? Let's say I put the number 2 here. So 3 times 2 is actually going to be 6, right? What if it is on this side? If my a is still 2, 2 times 3 is still 6. All right, both are still the same. So whether you write a3 or you write 3a, it will still give you the same result. Therefore, for multiplication, the unknown is going to be equal. It follows a commutative property. Very much like addition. Okay, so 2 times 3 equals to 3 times 2. Now, we move on to the last operation. Now, in division, okay, in arithmetic, yeah, just to throw in an example, like 12 divided by 3 is going to give you 4, right? But let's say I use algebra. So I'm going to throw in a letter. For example, let's say 12 divided by a equals to 4. What if I were to swap and I put a divided by 12? Okay, if a divided by 12, okay, then the thing is, will that gives me the same answer? Obviously, actually, it cannot. It will not. Okay, so the thing is, for division, okay, in this case, yeah, in division, if 12 divided by a, I can call a 3, right? The value of 3, then I will get 4. Okay, but the other side, a divided by 12. Okay, if a divided by 12, okay, let's say I don't put this as 3. Let's try to make it parallel. I put it as 4 as well. Okay, I just swap the a and the 12. So a divided by 12 and I end up with 4. My a actually takes on a value called 48. Because 48 divided by 12, then I will get 4. But in the first equation, a only takes the value of 3. Yeah, so for division, it follows the same rule as subtraction. A ends up with two different values, they are not commutative. Okay, so that is the first step. But there are many other things that we need to know about algebra so that we do not blunder and make mistakes. Okay, now let's look at the default setting for multiplication. When we have a combination of numbers and letters or just letters, the multiplication sign is always assumed and it is not written. That's why just now, like 3 times A, right? You just write it as 3A. You will not write the time sign there. Okay, so some typical examples will be 2 times B equals to 2B, or B times C, you just join them together, it becomes CB or it becomes BC, makes no difference. Okay, but if it is the same letter, D times D, I will call it D square, because D times D is the same letter, it becomes D square. All right, so that is the default setting when we use algebra. There is also a default setting for the first term in an equation, very similar to BODMAS. So BODMAS, you have actually learned that in primary 5 in the beginning of the year. That is when you learn the how to treat the operations, right? You always have to do the brackets first, then after that followed by the divide or the times, whichever appears on the left first. And finally, you'll do the subtraction and the addition, again, whichever appears on the left. So that is BODMAS. So when you have an equation, right, your very first term is the one where nothing is written. So when nothing is written, you must always assume it to be positive. Okay, so for example, 3p plus 2p minus 4p. Notice there's nothing written in front of the 3p. So I will assume that the 3p is positive. So I squeeze in that little plus sign just to show you. So the 3p can add the 2p. 3p plus 2p becomes 5p. And when I minus 4p, 5p minus 4p becomes 1p. And 1p, we will not put the 1 there. We will just write it as p. Okay. Now, if you cannot understand this part because you did not watch the video or you didn't understand the video, we can always replace the p with maybe an object. So it's something like 3 pens plus 2 pens and then minus 4 pens. Okay, so that will mean it is actually 3 pens plus 2 pens will get you 5 pens, and then you minus 4 pens, then you end up with 1 pen. So if you just end up with 1 pen, I'll just write a p over there. I will not put the 1. All right. Okay, so just a little bit more on the rules, and then after that we can actually do some of the exercises. Okay, now repeated addition must always be changed to multiplication. So you can think of our normal arithmetic, for example, 2 plus 2 plus 2 plus 2 plus 2. Will you end up writing 2, 2, 2, 2, 2? No, you don't. So similarly, algebra, if you have E plus E plus E plus E plus E, you do not just squeeze the 5 E's together and call it E, 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 E. That is wrong, yeah? Kaiser, well done. Yeah. You saw Kaiser has written something that he quickly cleaned it. Yeah, that's correct, yeah? Okay. So, another example. Will we write E plus E plus E plus E plus E equals to E with a little 5 on top? That is wrong. E with a little 5 on top actually tells you you are taking E to multiply by E and multiply by E and multiply by E and multiply by E 5 times. Okay, that is when you write that little 5 on top. So that one is called power. Yeah, which in primary school we actually learn only up to volume, which is cube. That's why you know about squares and you know about cubes. Okay, anything beyond that we do not teach in primary school. So another one. This is correct. So E plus E plus E plus E plus E, actually there are 5 of them. So you can say it actually means 5 times the E. And because we use 5 times the E, the times need not be written. We just write it as 5E. That's why just now you saw Kaiser, right? He wrote 5E. That is correct. Okay. So of course, if other things, if I have 3F plus 3F, a repeated addition of 2 sets of 3Fs, you just call it 6F. Okay, then just now we were talking about 1 not to write, yeah? Okay, so for example, if I have 4G minus 3G, we end up with 1G, but we do not write the 1. Yes, Kaiser, you just write the G. Okay, so be very careful. Yeah, we just write the G. What if the variable